Hi all, welcome to Soumya's Tech Talks. Today in C Programming Lecture 7, we are going to discuss about hexadecimal notation. In our further lectures, we will be mostly using this hexadecimal notation. That's why I want to cover this beforehand. So today first let's discuss what is the uses of hexadecimal notation. So where this is used frequently, I will tell you some examples. Like if you see Bluetooth, if you observe the Bluetooth or Wi-Fi MAC addresses, right? So those are represented in hexadecimal numbers. For example, this is the MAC address 001A 2B 3C something something. So these are all hexadecimal only. And also if you see the color codes, like we use color codes in GUI HTML, right? So that is also codes also represented in HTML only. This CD is 5C, 5C. This is also hexadecimal. If you see yellow, this is the code which is in hexadecimal. And also memory addresses like RAM memory addresses also represented in hexadecimal. In any system or any programming language, these addresses are always represented in the hexadecimal numbers. So in any format, like if you see decimal or binary, we have a digits. For example, in decimal, which is we call as base 10, right? So base 10, we have digits, what we use generally like 0 to 9, the digits we are using, right? Like in the binary system, we use 0 1. It is a base 2. So there is only two digits in the binary system, that is called 0 and 1. Like that, in hexadecimal also we have a digits, hexadecimal notation. So these are 0 to 15. So 0 to 9 is same as decimal only. It is same as decimal. But 10 to 15, so 10 is represented as A and followed by 11 is B, 12 is C, like this. So you have to remember the digits in the hexadecimal. So 0 to 9 and this A, B, C, D, E, F. So which is 10 to 15. Okay, now let's discuss how to convert a binary number into hex notation. So this is useful because as you see in many technical documents and specification document, there will be a lot of binary numbers, but binary numbers usually very difficult to read. So there will be a lot many ones and zeros in that. So where we cannot read it, understand it, it is difficult. But if we convert into hexadecimal, it is very easy to understand. So that's why always the binary numbers are converted into hexadecimal number before they want to present, before they present. So we will see the steps involved in it. So if you have a binary number which contains many zeros and ones, split that binary numbers into chunks of 4 bits. Means each part is or each chunk is a 4-bit part. Okay. Then convert each part into decimal first. So it will be the value will be 0 to 15 will come each part value. So then after that convert that decimal values for each chunk to hex. So then append all together and then add a 0x to it. So normally hexadecimal numbers start with 0x. 0x means that number is not decimal number or binary, it is hexadecimal. So you have to remember this 0x notation. So whenever you see 0x, it means it is a hexadecimal number. Now we will discuss practically how to convert a binary into hexadecimal. Let's say this decimal number 62380, so which I converted into binary, and this we will convert into hexadecimal and see what it results. So first let's divide it into this into 4 chunks like this. I have divided, and if you see we have to start from the right side because earlier we discussed, right, the most significant sorry, the least significant is on the right side. So we start from right side. So first chunk is this one 1100. If you convert to decimal, it is 12. Here I have a table which decimal to hexa conversion, like I have a decimal numbers on top 0 to 15, and then I have hexadecimal equivalent hexadecimal numbers in the bottom. So up to 9, 0 to 9, it is same. Both notation, the value is same. But 10 to 15, it is different. Like 10 in decimal, in hexadecimal, it is A. Like that, 11 is B, 12 is C. Like that, it will be there. So you have to remember this table so that whenever you can easily convert your data. So it is 12. So in hexadecimal, it is C. So now I will go to next chunk. If you see next chunk, 1010 in decimal, it is 10. In hexadecimal, it is A, because if you see the table, decimal 10 is hexadecimal A. So I will go to the next chunk. So it is 0011, which is decimal 3. In hexadecimal also it is 3. So I will go to the last chunk in this. So it is 1111, 4 ones, it is 15 in decimal. In hexadecimal, you can say it is F. So like this, you can convert any numbers, okay? So into binary numbers into hexadecimal numbers. See here we got F3AC, I have appended this 0x. So whenever you have hexadecimal number, you should add 0x to it, okay? Because whenever anyone reads it 0x, they understand that it is a hexadecimal number. It is not some string or some text. Okay, like this, any binary numbers you can easily convert to hexadecimal numbers. Here we discuss about how to convert a binary number into a hexadecimal number. Now we will see how to convert a decimal into hexadecimal number. So first we will take decimal number input, and what we will do, divide it by 16 like we did earlier for binary conversion, how we keep dividing with 2. Similar way we keep divide it with 16, and remainder we'll take and convert to hex and store it. And then quotient, whatever result comes, quotient we'll take to next step. If quotient is 0, then we will end our process, and whatever stored here we will take that as hexadecimal number. If quotient is not 0, we will again go back and again do the same step. So whatever comes, we will keep appending. Appending means we will add that digit next to it. Okay. So like this we do, we will convert into hexadecimal number. We'll see with a practical example. So first I will take this 62380, and what I will do, first I will divide it with 16. So I will get this quotient as this one and remainder as 12. So this 12 I will save. 12 means here it is C. So I will save this C in this step. So I will go to next step. Next step I will take this quotient in the previous step and divide it with 16. Now I got remainder as 10. So this 10 also I will store. 10 means 10 in decimal is hexadecimal A. So this quotient 243 I will take to next step. So here again I will divide with 16. So I will get 240, and remainder is 3, and 3 is hexadecimal, also it is 3. So I will store it. So next, whatever is remaining 15, I will divide with 16 again. So here it is 0 because 15 is less than 16, so it is 0, and I get 15 as remainder. So 15 means F. So I got each step, first step I got CA 3F. Okay. So now I will take normally when we write any binary or hexadecimal, right? So we will write uh, right to left to right, like right to left. So least this value will go to left, and the last one which came go to right. So we will write in reverse order. So F3AC. So F3AC. So I will append 0x so that we are representing that it is a hexadecimal number. So this is the way we can convert a decimal number into hexadecimal number. You can take any number, even big numbers also you can take. Same way you can convert, and once the result comes, you write the result in the left to right. Means starting one will come to left, after that next one, after that next one, after that next one, and add a 0x to it. Now we see earlier how to convert a binary into hexadecimal and also decimal into hexadecimal. Now we'll see the reverse process. Like if you have hexadecimal, how to convert into a decimal number again. So here you will have a hexa number, and hexa number will be text form, right? So it is, you will take the left one. Like if you have a 0x00ff something, so from the left side you will take each digit from the left, and you will convert each one into decimal and multiply it with 16 and store the result. So whatever result comes, add it. Initially the sum is 0, so add this whatever you got it here, you keep adding it and store it. So repeat same step until no more digits left. So from the right side to left side you keep doing all this and add the sum, and at the end, once you done with all the digits, you will get the decimal number. We'll see this with one practical example. Okay, I will see same this earlier whatever we done, F3AC, this hexadecimal number I will take, and I will convert this each one into decimal. Like F is 15, hexadecimal F is 15 in decimal, 3 is same, A is 10, C is 12. So I noted like this, and then this is the most significant bit. Okay, so we are doing from, this is left to right. Okay, so here it is most significant, it is least significant. So first, as we done the binary conversion, so here it is the value of this position is 16 power of 0, 16 power of 1, 16 square, 16 3. If you have more, so you have to add one more power like 16 power of 4, 5, like this it will go. But right now we only have 4 digits, so 4 digit, first one is 16 power of 0, 16 power of 1, 16 square, 16 3, like that. So first one what we will do, it is decimal 15, so I will multiply 16 power of 3 into the value which is 15, so I will get some value. So 16 power of 3 is this one, and 15 to 15 I will get this. Okay, again the next step I will do here. Here the position value of this position is 16 square, and the digit is 3, so I will multiply and I will get this again. Again I will do same for this one and same for this one. Now I will add all together, I will get the my decimal number. So what we have to do, so here once you get the hexadecimal number, you have to split it like this. Okay, from left to, from right to left, and so rightmost is 16 power of 0, this digit position value is 16 power of 0, the next one is 16 power of 1, 16 square, like this you will keep doing. Each digit you have to multiply with corresponding position value. Like C, the position value is 16 power of 0, so you have to multiply the C means 12 in decimal, so you have to multiply with that. Like that you will keep doing from right to left, and whatever result comes you have to store, and at the end you have to sum everything, then you will get the decimal number. So this is how we convert hexadecimal to decimal. Okay, today we learn about hexadecimal format, and we will end here. We will continue on the bitwise operators in C programming language in the next lecture. Until then, happy learning. Please share this tutorial with your friends who are willing to learn C programming language and advanced concepts.